Now next we will discuss simple harmonic motion of the particle on the horizontal axis. So what is happening here? We have two charged particle Q and Q, and in between these two particle we are putting one Q naught charge particle. It is also positive, everyone. So this all charges are positive here. Now what is happening here? Separation between these two charges is 2a. There is separation between the two charges. Now we are applying some force on this Q naught charge. So we are applying some force on this Q naught charge. Let's suppose toward the left here. So due to this force, right now it is here, and displacement of this charge is happening. It is x, everyone. Correct. So this is x. So this distance will be how much? Because distance between Q and Q naught initially is a. Initially this distance is a, everyone. Now displacement we are doing here x. So now this distance is becoming a minus x, and this distance is becoming a plus x. So now the next thing is what? On this charged particle, how much net force is acting? Because here we are finding, we want to find out omega value. Angular velocity we want to determine here, angular frequency we want to determine here. Correct. So what we can do it here, right now on this charged particle, let's suppose toward the right F2 force is acting, and this force is, let's suppose, F1. Correct. So what is the value of F2, everyone? If I will write F2 and F1, so F2 can be written as what? It is K Q Q naught, and now the separation between Q and Q naught is what? It is A minus X. So we will put here whole square also. Then F1 K Q Q naught, and separation between Q naught and Q is what? It is A plus X. So here we will write A plus X whole square. So F2 equal to K Q Q naught by A minus X whole square. F1 is K Q Q naught by A plus X whole square. Correct. Now applied force equal to restoring force. This equation we will write. So what is the applied force here? Applied force we are applying on the charged particle. So initially it in the center. It is in center. We are applying some force. So for the SHM we should have some restoring force toward the mean position. So here restoring force we are getting due to the electrostatic force. Correct. So restoring force should be present for the SHM. So here we have restoring force, and applied force can be written as MA dash. And what is the restoring force? Restoring force can be written as F1 minus F2. So what is the value of F1? It is K Q Q naught divided by A plus X whole square minus K Q Q naught divided by A minus X whole square. Correct. This thing we will get. Now the next thing is what here? M A dash equal to K Q Q naught 1 by A plus X whole square minus 1 by A minus X whole square. Correct. Now simplify this, then let's see what we will get. MA dash equal to So if you will take LCM here everyone, so what I will get here, what we will get here, here we have a plus x whole square minus 1 by a minus x, a minus x whole square, correct? So if we will take LCM, then we will get 4ax a square minus x square whole square. This is stuff we will get, correct? So we will get here k q naught and 4x minus, and I am writing here 4ax divided by a square minus x square whole square. So this thing we are getting, correct? So minus sign I am putting here. Now the next thing is what? The next thing is what? This amplitude is very small, means x is very small. When it is doing SHM, then x should be very small. So x tend to 0. So x square is approximately equal to 0 everyone. When x is very small, then x square is very small, so it is approximately equal to 0. So this thing we are getting. Now let's see next step everyone. X square is 0. So we have m a dash equal to minus k q naught 4ax divided by a power 4. So m a dash equal to minus k q naught 4. This is a power 4, this is a, so this is a power 3. So 4x divided by a power 3, correct? Now the next thing is everyone, we will compare with a standard SHM equation because we are looking for the angular frequency, correct? So m we will put on this side. So now we have oscillation is equal to minus k q naught 4 by MAQ into x, and standard SHM equation is a is equal to omega square x. So whatever we have with this omega with this x everyone, that is omega square. So here this is equal to omega square everyone. So we got it omega value. So omega equal to what? It is under root, because omega square equal to this. So omega equal to what? It is under root k q naught 4 divided by m AQ. This thing we will get. This is the omega value. This is the angular frequency. Now if I will write linear frequency, so it is f equal to 1 upon 2 pi under root 4k q naught by MEQ. This thing we will get. This is the linear frequency. So now we have angular frequency as well as we have linear frequency also. Let's see next case everyone. SHM the particle on the vertical axis. So let's see it. What is happening here? We have two charges. Plus q and plus q once again. In between these two charges, we have q naught charge. And we are applying some force on this q naught charge, so it is going up. And let's suppose at t equal to t time, it is present here. And it should be negative everyone. If we are talking about the simple harmonic motion about the SHM, so we should have restoring force. And if it is negative charge, then only we are getting restoring force. If suppose it is positive charge, then what will happen? It will go up. We are applying force in upward direction and it is also going in upward direction. So it is not doing simple harmonic motion if it is positive. So it should be negative everyone for the simple harmonic motion. Then only we are getting restoring force, correct? This is the necessary condition for the simple harmonic motion. Restoring force should be present on the particle. And this distance is a everyone from here to here. and this distance is y. So this is a, this is y, everyone. So this is what, this is under root a square plus y square. From the Pythagoras theorem we get this distance of between the plus q and q naught charge. Now make it FBD of this. This is minus q naught charge. So here we have F force in this direction, and let's suppose this angle is theta, everyone. This angle is also theta. If this angle is theta, so this angle is also theta. All right. So if this angle is theta, so this angle is also theta. Now the next thing is what? If we will resolve this F in horizontal and vertical direction, so this component is what? If I will resolve this F in vertical direction, so this is F cos theta. So F cos theta plus F cos theta is 2 F cos theta. This is the total restoring force, everyone. And here we have F sin theta and F sin theta. This both will get cancelled out. Correct. Now simply we will write applied force, because if any particle is doing simple harmonic motion, then that particle should follow this equation. Applied torque is equal to restoring torque, or applied force is equal to restoring force. So applied force is how much here, everyone? It is mass into acceleration. Acceleration I am representing with a dash. Restoring force already we have, it is 2F cos theta. Now we have required F value and cos theta value. If you will look the geometry, everyone, so from the geometry, cos theta value is what? It is the perpendicular by base. Correct. Cos theta is what? It is the base by hypotenuse. Correct. So cos theta is the base by hypotenuse. So it is y by root a square plus y square. This is the value of cos theta. Alright. Now we want F value also. So force between Q naught charge and plus Q charge can be written as, magnitude of force can be written as K Q Q naught divided by separation between the charges, which is a square plus y square. Because we are doing here whole square, formula is k q1 q2 by r square. So here it is root a square plus y square. If you will do it whole square, so it is only a square plus y square. Now m a dash equal to minus 2 f value is k q q naught divided by a square plus y square, and cos theta value is what? It is y by a square plus y square power 1 by 2. Now we will simplify this. So if we will simplify this, then we will get m a dash is equal to minus 2 k q q naught y divided by a square plus y square power 3 by 2. This thing we will get. So now the next thing is what here? See, when the particle is doing SHM, then amplitude should be very small, correct? So y is very small, everyone. Y tend to 0. Then y is approximately equal to 0. So this thing we have, this condition we will use. Now let's see it next page. So we have, correct, y square is 0. So this term will get 0, everyone. And m we will put on this side. So we have now a dash is equal to minus 2 k q q naught y by a square power 3 by 2. So 2 will get cancelled. So it is aq. Correct. And here we have mass also. Now standard acceleration is what? A dash is equal to minus omega square y. This is a standard SHM equation. Now compare this equation with the standard SHM equation. So we will compare So this term is equal to omega square. So omega value is how much, everyone? Omega is under root 2k q naught by m eq, and this is the final answer. This is the angular frequency. So on the vertical axis, if the particle is doing SHM, then angular frequency is 2k q naught by MEQ. So I hope this thing is clear to everyone. Let's see next topic, everyone, Coulomb's law in vector form. So first of all, we are taking here XY plane. This is x-axis and this is y-axis, and this is origin 0, 0. And in this xy plane, we have two charges, Q1 and Q2. So this is Q1 charge and this is Q2 charge. And the position vector of this Q1 charge is R1, and the position vector of Q2 charge is R2. So this is R1 and this is R2. And separation between Q1 and Q2 is R here. So this is vector R. We are assuming this both charges positive, plus Q1 and plus Q2. So between Q1 and Q2 we have repulsive force. So the direction of force on this Q2 charge due to the Q1 can be written as F21. This is F21, everyone. F21. And this is the direction of F1, force on the first charge due to the second. F12. Alright. And according to Newton's third law, this F12 and F21 both are action reaction pair, because according to Newton's third law, always forces are acting in pairs. So this F12 and F21 is action reaction pair. That's why F21 equal to minus F12. So direction is opposite but magnitude is same. That's why we are writing F21 is equal to minus F12. Now we are writing here F21, everyone. Force on the second charge due to the first. F21. So when we are writing force on the second charge due to the first charge in the vector form, then we have required two things. The first thing is what we have required here, magnitude. Second thing, we have required direction. So force between 2 and 1 can be written as K Q1 Q2 by R square. And direction is R cap. So R cap is the unit vector in the direction of F21 force. So R cap can be written as vector R by mod R. So if you will divide any vector with the magnitude of that vector, then we will get unit vector. And you can see it here, direction of R vector and the direction of F21 vector is same. Alright. So F21 force direction, if you want to represent, so we will represent the direction with the help of R cap vector. Now the next thing is what? We will put this both the values. So F21 can be written as K Q1 Q2 by R square, and R cap can be written as R by mod R. Now the next thing is what here? See, this R square is what? It is magnitude only, correct? This is magnitude, everyone. So F21 is equal to K Q1 Q2 by mod R Q by R vector. This is the value of F21. Now, if I will use here triangle of addition, because here we have three vectors R1, R and R2, and if we will apply triangle of addition, so what relation we will get? Let's see it, everyone. R1 plus R equal to R2, correct? R1 plus R equal to R2. So from here, R value is what, everyone? R can be written as R2 minus R1. This is the value of vector R, R2 minus R1. Alright, so this R value, if I put here, so F21 can be written as K Q1 Q2 and R is what it is, mod R2 minus R1 Q and R vector is what it is, R2 minus R1. This is the value of vector R. Alright, this thing we are getting. Now, if you want F12, so according to Newton's third law, correct, this F12 and F21 both are action reaction pair. So F12 equal to minus of F21, and F21 value already we are putting here K Q1 Q2 R2 minus R1 divided by mod R2 R1 Q. This thing we will get. This is the value of F12. If you want to multiply this minus sign inside this bracket, you can do it. Then you will get R1 minus R2. So now we have Coulomb's law in the vector form, everyone. So I hope this thing is clear to everyone, how we can write on Coulomb's law in the vector form. Let's see next topic, everyone, superposition principles. So let's see superposition principle for the electrostatic force. So what statement we have here? The total electric force on the charge from multiple other charges is the vector sum of individual forces exerted by the each charge independent of the influence of the other. So let's suppose we have n number of charges in the system. So let's see it, everyone. Let's suppose it is Q2. This is Q1. This is Q3. And this is Qn. So we have n number of charge in the system. So first of all, what we will do it according to principle of superposition. We will write here force on the first charge due to the second, which is F12. Now force due to the force on the first charge due to the third, it is F13. Then we will write force on the first charge due to the nth charge, it is F1n. Alright. So first of all, what we are doing here, we are writing individual forces. So force on the first charge due to the second is F12. Force on the first charge due to the nth charge is F1n. Force on first charge due to the third charge is F13. So first of all, we are writing individual force between all, and then we are writing vector sum of this all the individual forces. So now net force on the first charge can be written as F12 plus F13 and then F1n. And this is the net force on the first charge. So like this we can write down superposition principle for the electric force. First of all, we are finding here individual forces between all, and then we are doing vector sum. Then we will get net force on that charge, everyone. So I hope this thing is clear to everyone. Let's see this question, everyone. Four bodies of equal charges Q are placed at the corner of the square of side A as shown. Find the magnitude of net electrostatic force exerted on any one charge by the other charges. So if we will look here, we have one square and the corner of the square plus Q charges present at every corner, correct? And the separation between all charges is AA here, correct? We want net force any one charge. This is the question. So let's see how we can do this question, everyone. So first of all, I'm giving here number so we can identify easily. Let's suppose this is charge number first, this is second, this is third, and this is fourth. So total we have four charges. Now we want here net force on any one charge, correct? So I am choosing second charge and I will find net force on the second charge. This thing we will do it. So first of all, I'm writing force between second and first charge. So this is F21. So first of all, I'm writing force on the second charge due to the first, correct? Then I'm writing force on the second charge due to the third, F23. And force on the second charge due to the force is fourth charge is F24. So this is F24, everyone. All right. So now the next thing is what? This is what, everyone? This is F21. This is F23. This is F24. All right. And this is square, everyone. So if I will draw here one diagonal, so this diagonal is making 45 degree with the horizontal and from vertical. So this angle should be what? It should be 45 degree, and this angle is also 45 degree. So this angle is 45 degree and this is also 45 degree, correct? If I will see the magnitude of F21 and F23, magnitude is same, everyone, because the separation between the charges is same and the magnitude of charge is also same. So magnitude of F21 and magnitude of F23 is same, correct? So magnitude of F21 and F23 is same. Now the next thing is what here? If I will write the magnitude of F21 and F23, so it can be written as what, everyone? It is K charges is Q here, so KQ square, and the separation between the charges is A here, so KQ square by A square. This is the magnitude of force. All right. Now the next thing is what here? Now the next thing is what? Resolve this F21 in the along the diagonal, correct? So if we will resolve this, then let's see what we will get, everyone. This is F21. So one component is here, and with this diagonal it is making 45 degrees. So this is what? This F21 sin 45, correct? And if I will resolve F23 in this direction, so this component is F23 sin 45, correct? And we can see it here, F23 and F21 has same magnitude. So this and this will cancel out to each other. So along the diagonal, now net force we have F24 plus F23 cos 45 plus F21 sin 45. So I am writing here net force on the second charge is F24 plus F21 cos 45 plus F23 sin 45. All right. So this thing we have, so not a sin 45, cos 45. See, direction of F2 force, F21 cos 45 and F23 cos 45 is same, because we are resolving here F23 in this direction and along the diagonal, correct? So direction of F24, F21 cos 45 and F23 cos 45 has same direction. That's why simply we are adding this all forces. So we will get net force on the second charge. So F2 equal to F21 cos 45. So 2 1. So it is KQ square by A square, correct? And if we will add this and this, so it is 2 F21 cos 45. This thing can be written as, all right. And F24 is what? KQ square by root 2. See it. What is this distance, everyone? What is the distance of diagonal? This is A, this is A. So from the Pythagoras, it should be root 2A. So I am writing first of all F24. So it is K Q square, and the separation between charges is what? Root 2A. So root 2A square we will write here, plus F21 cos 45. So F21 cos 45 and F23 cos 45 is same, correct? Magnitude is same. So directly I am writing 2 K Q square A square cos 45, correct? Combinedly I am writing this both. Now the next thing is what? F2 is equal to K Q square K Q square divided by 2A square plus 2K Q square by A square cos 45 is 1 by root 2. So KQ square by A square. If I will take common, KQ square by A square. So now we have 1 by 2 plus root 2. This is the value of F2. So now we have F2 also. So net force on the second charge due to the other charges is what it is this, KQ square by A square 1 by 2 plus root 2. This much force is acting on the first charge also, third charge also, and fourth charge also, correct? Equal amount of force is acting in this all the charges. So I hope this thing is clear how we can find out, correct, this net force on any one charges. Let's see next question, everyone. Three identical particles of equal charges plus Q are placed at the corner of the regular hexagon of side A as shown. The net electrostatic force on plus Q, which is placed at center O is. So this is the question, everyone. So we want here net force on this Q charge, which is present at the center. So how we will do it this question, everyone? Here charge is present at A, at B and C, correct? And at this plus Q charge we want net force due to this other. So first of all we will find here individual forces. FOA, then FOB, and then FOC. So first of all we are writing individual forces FOB, FOC and FOA. All right. And this is the regular hexagon, everyone. So this all angles are 60 degree, and this length is A here. This is also A, this is also A. All side length is AA here. And this angle is 60 degree. So this is also 60 degree and this is also 60 degree. Now what I am doing here, I am making FBD of this Q charge, which is present at the O. So this is Q charge, everyone. And here we have FOC, FOB and FOA. So FOA, FOB, FOC. So this angle is 60° and this angle is 60°. Correct? Both angles are 60 degree here. Now the next thing is what here? We will resolve the FOC and FOB. So if we will resolve, so this is FOC sine 60, and this is FOA sine 60, and this is FOB cos 60. All right, so what I can do it here, I'm writing here FOC cos 60 plus FOA cos 60. All right, so net force on this O charge is what? It is FO equal to, see, FOB, FOC cos 60 and FOA cos 60 has the same direction. So directly we are adding like a scalar because they all are in the same direction. And angle is 0. So directly we can add here FOB plus FOC cos 60 plus FOA cos 60. Now the next thing is what here, everyone? If you will see distance between O and A, O and C, it is same, and O and B is also same. It is AAL. It is only AA. Correct. So magnitude of force of FOA, FOB, and FOC is same. So I'm writing here FOA, FOB, and FOC is same because distance is same, magnitude of charge is also same. All right. So now we are putting all values here. So let's see what we will get. I'm taking next page. So what is the FOB, everyone? FOB is KQ square by A square. Look at once again this diagram, everyone. Distance between O and A, O and B, and O and C is AA. Charge is Q. Correct? So here it is KQ square by A square plus KQ square by A square. Cos 60 value is what it is, 1 by 2 plus KQ square by A square into 1 by 2. All right. So now the next thing is what here? KQ square by A square plus KQ square by A square. Half is full, everyone. So now finally we have 2KQ square by A square. This is the final answer. So finally, which options we have, if we will check here, we are getting option number B. B is the correct answer, everyone. 2KQ square by A square. So I hope this thing is clear to everyone. No one has doubt here. All right. So like this we can do it. First of all, we are finding the individual forces. Now we are adding all the forces and then getting answer. So this thing we are doing. So here in this question we are using superposition principle, and in this question also we are using superposition principle. Let's see next topic, everyone. Electrostatic force on charge trapped in the medium. So in the first picture, what is happening here? Two charges is present in the vacuum and the separation between Q1 and Q charges are. So here force in the vacuum can be written as Fv equal to Q1 Q2 by 1 upon 4 pi and it is present in the vacuum. So permittivity of the vacuum is E naught, so 4 pi epsilon naught, and the separation between the charges is R. So Q1 Q2 by 4 pi epsilon naught R square. This is the force between two charges in the vacuum. If I will write force between these two charges in the medium, so it can be written as Fm equal to Q1 Q2 by 4 by Em, where Em is what? It is the permittivity of the medium, correct? So Em is the permittivity of the medium and separation is again R, so we are writing here R square. So when these two charges is present in the vacuum, then force between these two charges can be written as Q1 Q2 by 4 pi epsilon naught R square, and when it is in the medium, then it can be written as Q1 Q2 by 4 pi Em R square. Now if I will take ratio of this both, then what we will get? Force in the vacuum divided by force in the medium. So Fv by Fm is equal to what? Sit here Q1 Q2 4 pi R square is common in both terms, correct? So this will get cancelled out. Now we have what? Em by E naught. And permittivity of medium by permittivity of free space, if you will take ratio of this both, then it is equal to relative permittivity. And this ratio is also known as dielectric constant, and dielectric constant will represent capital K at everyone. So we will represent this this dielectric constant with a capital K. Er is the relative permittivity and it is the ratio of permittivity of the medium by permittivity of the free space. So this relation is very important for us everyone. So write down this relation. Now let's see one example everyone on the basis of this relation. What type of question can come from here from this relation? Let's see it. So let's suppose when two charges is present in the vacuum, then the force between these two charges is 80 Newton. Now we are putting these two charges in medium and dielectric constant of the medium is, let's suppose, 80. So now what is the force between these two charges when we will put in the medium? So when it is present in the vacuum, then the force between these two charges is 80 Newton. And when we are putting in the medium and the dielectric constant of that medium is 80, then what is the force between these two charges? Separation between the charges we are not changing. Alright, so this is the question everyone. So relation already we have Fv by Fm equal to K. This relation we will use, correct? So Fv by Fm equal to K. So we are looking for what? We are looking for the force in the medium. So Fm equal to what? It is Fv by K. Fv equal to how much we have? It is 80. And what is the value of K? K is 80. So now force in the medium is how much everyone? It is 1 Newton. So this is the force in the medium, 1 Newton. So I hope this question is clear to everyone, and what type of question can come from this relation. This thing is also clear. Let's see it. Next question everyone. When air is replaced by a dielectric medium of force constant K, the force of attraction between two charges separated by the distance. So here we have four options and we want to check it which one is correct. So let's see it how we can do this question everyone. We know that force in the vacuum divided by force by medium ratio is Fv by Fm ratio is K everyone, where K is what? It is the dielectric constant. So Fm equal to what? From this relation can be written as Fm equal to Fb by K. Alright. So force in the medium can be written as force in the vacuum divided by K. So you can see it here, force in the medium is becoming K time less here. This thing is happening, correct? So now the force is decreases K times when we will put in the medium. So the correct answer should be what? It should be option number A. Decreases K times.